Welcome again, everybody. All right, we're finishing up section 5.4 right now. We've already learned all the basic content that you need in terms of how you graph and analyze rational functions, but what I still need to do is give you a couple of problems where you're problem solving using rational functions and their graphs. And so that's the goal here, is that you'll solve problems using graphs of rational functions. And what I've done is I've made up one problem that's going to have several parts to it. It will take a decent amount of time for us to do, but we're going to use what we know about rational functions in order to answer this question. All right, and so this is a whole lot. I understand if you need to pause and kind of write it down, that's fine. The problem says that the cost of renting a bouncy castle for a party is $15 per hour plus $100 for delivery and setup fees. Now, I don't know if I've seen any bouncy castles around Morocco. I'm sure they have them. If you don't know what a bouncy castle is, look it up. Lots of fun. Great for kids' parties, of course. Anyway, that's a side note. $15 per hour plus $100 for delivery and setup fees. Well, what we're going to do, a couple things on this slide. We're going to write a function that's going to calculate the total cost of the rental for T hours. So if you rented it for 2 hours or 9 hours or 37 hours, it will tell you what the total cost is. And then after that, we're going to go ahead and try to write a function to calculate the average hourly cost for T hours. So on average, did you pay $70 per hour? Did you pay $30 per hour or $25 per hour? We'll write a function that would help you determine that for any given amount of time. Now, I'm hoping that your instincts are already pretty good on how we're going to do this first part. Writing the function to calculate the total cost of a rental for T hours. There are two things included in calculating that cost. Let me write something real quick. All right, remember our cost is going to be represented by C of T. All right, the two things involved in the cost are the hourly fees plus the one-time $100 that they're going to pay to bring this thing out to you, to set it up, and then to take it away whenever you're done renting it. So the hourly part depends on how many hours you rent it for. So you're going to multiply the number of hours that you rent the bouncy castle for by 15, and then you're going to add in that one-time fee, correct? So there's a function to represent the total cost of the rental for how many ever hours you would like to find it for. So if I wanted to know what was the total cost for 3 hours, well, you'd have 15 times 3 plus 100, and you'd tell me it was $145. All right, next we're going to calculate the average hourly cost. Or average there, very key to what we're trying to do here. Now think about how you calculate an average, and this becomes a pretty simple task for us. Generally speaking, whenever you calculate an average, and let's do this in terms of an average cost, an average cost would equal the total cost divided by time in an instance like this. It could be divided by a number of units in another context of a problem. So the total cost divided by the time will give us the average cost of the rental. Now for our problem, the total cost is what we wrote above. You calculate the total cost for this rental by multiplying 15 times T and then adding in the $100 one-time cost. And then the amount of time, well, that's just represented by T. There's our function that would model the average cost of renting this bouncy castle for T hours. And notice that that's a rational function, right? You've got a polynomial divided by a polynomial, or a linear function divided by a linear function, more specifically in this case. Got some more questions to ask you in regards to this bouncy castle. And what we're trying to accomplish here is we're going to try to see if you can put meaning to some of the things that are parts of the graph of a rational function. For instance, a word we've thrown around a whole lot in this chapter so far is domain. And I would like us to talk about what the domain of this function would be in the context of the problem. Because it's going to be a little bit different than what the domain would be if I just gave you the related function without putting it in the context of this rental problem. if this weren't a rental problem, what you would tell me is that the domain would include all values of t except for, all real numbers except for t equals 0, right? Because you can't divide by 0. But t does represent time. Time can only be positive. So not only can we not let t be 0, because we can't divide by 0, but we can't let t be negative just because of the problem that we're in. And so our domain for this problem would be that the time involved has to be greater than 0 hours. Alright, next we're going to go ahead and sketch the graph of this function. And we're only going to sketch the graph that will be part of the domain. We are going to limit the domain as well. We're not going to go all the way to an infinite number of hours. We're going to stop at 12. Probably if you're renting something like the bouncy castle for your kid, you're not going to do it for more than 12 hours. I don't know, maybe you would. At any rate, sketch a graph for the function over the interval from 0 to 12 for t, not including 0 because that's a vertical asymptote, remember? So I've made a table of values here to aid you in what we're doing. You need to plug in the numbers 1, 2, 6, and 12 into our function, which I've included here at the bottom of the screen. And I want you to keep in mind what the horizontal asymptote is as well. We've talked about the vertical asymptote. Horizontal asymptote needs to be a part of your thought process when you make the graph. See what you can do here. There you have the coordinates of the points that we're going to plot. And the horizontal asymptote, if you didn't figure that out already, would be this. Y equals 15. And if you're not certain of how I got that, well, let me show you really quickly. This function, our rational function, was a linear function divided by a linear function. Remember you do that whole a over c thing? Well, you had to recognize that this denominator was the same thing as 1t plus 0. And then if you just make your ratio out of your a and your c, 15 over 1 is 15. That's where they came from. All right, so at this point you ought to be able to complete the graph. Just make sure you choose the appropriate intervals for each axis. I think going by ones is fine on the horizontal axis the way that I've got it. I'd probably go by 5s or 10s at least on this axis. You'll see what I choose whenever you come back to check your answer after you're done with your graph. Alright, didn't realize the clock was still running on me there. But at any rate, you've got the graph in front of you now. Sorry about the silence there. We do have the graph. And, well, there you go. Now you can kind of look at that graph, and if you want to know what the average cost was after 10 hours, you could kind of estimate that using the graph. Or if you wanted to know how long it would take before the average cost is, say, $30, well, you could use the graph and figure out, that's pretty close to 6.5 or 7 hours that it would take in order to reach that average cost. All right, well, last thing I want to ask you here is this. I want us to find, I don't know why I put a question mark at the end of something that starts with find, but I want us to find the horizontal asymptote for A of t. Oh, there it is. And I want us to determine what meaning does this have in the context of this problem. Well, we already found the horizontal asymptote, so we can go ahead and write y equals 15, or I suppose A of t equals 15 is appropriate in this case. And then let's go back and look at the graph and see why that would be appropriate. Or rather, not why it would be appropriate, but what the meaning behind that would be. Now, notice what's happening is that as the graph is getting closer to the horizontal asymptote, the cost of the hourly cost for renting this bounty castle is getting closer and closer and closer to that very value, $15 per hour, right? So, what the horizontal asymptote represents then is what the cost would be if you were to rent this bouncy castle for an infinite number of hours. All right, it's what the cost is approaching as time continually increases. And that's what I'm going to write. I'll say this indicates that this indicates that the average hourly cost for the rental will approach $15 as time increases. All right, you know what you need to know about rational functions at this point. Thanks for your hard work on this chapter, and I will see you next time.